Hey folks, today I'm going to do an algorithm that involves powers of a number. So what it's looking for is if you had 2 to the 3, that equals 8. 2 times 2 times 2 equals 8. So a function x to that takes x and n, x being your base number, n being your exponent, like 3. This is kind of a tricky one. I've spent time on this one. I'm going to see if I can kind of redo it for you guys and walk through a recursive way of doing this. You could have used a while loop, perfectly fine. But I thought it'd be kind of a really interesting case of recursion. So here we go. Before you get into this one, you have to know some of the math rules, and hopefully if this actually was in an interview situation, they would give this to you. Maybe not. X to the 0 equals 1. I would call that a fast exit. X to the 1 equals x. Sounds like a pretty decent base case. X to the negative 1 is equal to 1 over x to the n. X to the n is equal to x to the n over 2 times x to the n over 2. And x to the n is equal to x to the n minus 1 times x. These two are pretty important. Okay, so what this is basically, what we can demonstrate is 2 to 3. So we can break it down in here. 2 to the 3 is equal to, well, we need to be able to half 3, right? So we need a case where we can half 3. All right, follow me. So we need a case for a negative, for a odd exponent. So I've translated these base cases into the code to save some time. 0 return 1, n is 1 return x. If n modulo 2, so we're trying to figure this odd, if we have n modulo 2 is greater than 0, I apologize if you're hearing my snoring cat behind me. She's just snoring. Yeah, if greater than 0 means it's odd. How do we deal with that? So we would take this little number right here, and it's being applied here. Return a recursive call, and we're going to use x and n minus 1, so x being still 2, n minus 2 being 2 times 2 is still x. That looks like a fair path to go down. Okay, but we still need a way to then recur on this. So how do we get closer and closer and closer to a base case, like 0? Like 0. All right, how do we get closer? So let's do something like this here. So we will return powers, and we'll just keep dividing n in half. Okay, great. So well, this here is going to come down to here. So I have 2 and 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. Okay, cool. This comes through here. Oh, n is equal to 1. That's fantastic. Or we could look at this. It would catch that, and yes, that'd be great and everything. And as a matter of fact, it would go pretty fast. So that returns x. X is 2. 2 times 2, and that would come plug back up into here. 2 times 2 times 2, and that will give you your 8. Okay, real quick, let's see how we can cover all odd situations of n. Let's say that, yes, this made it actually very fast and less processing time, but let's say we didn't do that. It would still get caught. It would still get caught right here, because let's get rid of that real quick. Say this as fast as I can. So 1 module 2 is greater than 0. So we had to this part we still need to do another return. So this part in itself would be powers of 2 n minus 1 is 1. Powers 2 and 1, and that's also times x. Times x is 2. All right. Or, I'm sorry, n minus 1 in this case was actually 0. Okay, cool. N is 0, return 1. So this is now 1. And 1 times 2, because right, I need to have, we're doing this here. That's times 2, and that equals 2. So this one is now 2. This one is now 2. And then our original x we had here is 2. So 2 times 2 times 2 is also 8. That's it for now. I'm going to pause the video. Stay tuned if you want to just see the code so it can be a lot clearer that way. Otherwise, like, comment, share, let me know what you think. And I will talk to you guys next time. I'm just looking for the pause button. All right, stay tuned for code. If not, have a great day. Okay, so I've just sat back down here at the desk, and I've got the code pulled up here. Let's take a look at the code. Okay, so I just made the function here. N is 0, return 1. If it's odd, we called power with x and n minus 1 multiplied by x. If it's less than 0, we didn't go through that case, but I can show you that at least that it works. This is how you would do it. When your exponent is 0, you just put, like I said, is back there. In that case, x to the negative n is 1 over x to the n. And that's exactly what this case is doing. Anyway, I just want to show you guys the code. I had 2 cases that I ran through here, 2 and 3, and then 3 to the negative 1. So 2 to the 3 is 8. 3 to the negative 1 is 0.3333, or 1/3. That's about it. You guys have a great day. Let me know what you think. And I'm just going to keep going. See you guys later.